And then you say, okay, but what's the big takeaway from this? Because, you know, we did all this work, we got this formula, cool, but no, what can we really get from this? Well, you know how cosine works. What? Go to the unit circle. The x is the cosine, and the y is the sine. And since we're talking about an angle between two vectors, we were using the angle that was only between 0 and 180 degrees. And between 0 and 180 degrees, there's only a single point up at pi over 2 at 90 degrees where the cosine is 0. Cosine, the x position, where you are horizontally, if you're between 0 and 180 degrees, there's only one point where your horizontal position is neither right nor left. That's when you're on the y-axis at the top of the unit circle. So when you look at this cosine measure here, the cosine measure here is only 0 when the two vectors meet at a 90-degree angle. So when you talk about your dot product is going to be 0 only when theta is 90 degrees. And now, what about for other thetas? What if your theta was between 0 degrees and 90 degrees? Well, you know that between 0 degrees and 90 degrees, your cosine is positive, so that would mean that this value is positive. But what about the other two values of norm of A and norm of B? Well, norm of A and norm of B, by virtue of being something squared plus something else squared, square rooted, they're going to be positive. Square numbers, you get something positive. Add positive things to positive things, you get something positive. Take the square root, you still get something positive. So A and B are going to be positive. If cosine is also positive, namely between 0 and 90 degrees, your dot product's going to be positive. So when your angle is acute between your two vectors, your cosine is going to be positive because, what, in the first quadrant between 0 and 90, your cosine is positive. You're to the right side of the unit circle, and a positive times a positive times a positive is positive, so your dot product is positive in that case. Cosine 0, that was the 90-degree case, which we've already accounted for, and what about when cosine is negative? Well, since we're talking about an angle between two vectors, and since we're considering that angle to be between 0 and 180, that's only possible in terms of cosine being negative if you're between 90 and 180. Between 90 and 180, you're to the left side of the unit circle, the cosine is negative, so positive times negative, your dot product would be negative. So when your theta is obtuse, your dot product is negative. And that fact that we've got here in the bubble, that is hugely important. That is a big leap forward here, because working through the logistics of the math here, what we can say is that dot product is positive when the angle is acute, negative when the angle is obtuse, and 0 only when your vectors meet at 90 degrees. Only when your vectors are perpendicular. And now, as I say that, I need to define one more term. When A and B are not 0 vectors, but A dot B is 0. What would be this situation? This is the situation where A has some positive length, where B has some positive length, and their dot product is 0. This is the case where the cosine is 0. This is the case where you've got the vectors meeting at a 90-degree angle. We say A and B are orthogonal. Now, what do we mean by orthogonal? Because you say, well, wait a second, orthogonal. This is a situation where the vectors meet at 90 degrees. Don't we call that perpendicular? Yes, orthogonal is a corresponding notion of perpendicular. Because think about this. While the word perpendicular is used concretely to describe two-dimensional things and three-dimensional things meeting at 90-degree angles, this notion of orthogonality, which relates to dot product, could extend to n dimensions where n was bigger than 3. So, long story short, the word orthogonal is code for perpendicular, just like the word norm is code for length when you extend out to n dimensions. Orthogonal, perpendicular in your mind's eye can be thought of virtually identically. It's just orthogonal is a fancier word to describe that something when you might be thinking of things in higher dimensional space. Just like norm is a fancy notion of length, whereas norm and length in your mind's eye can be thought of virtually identically because they're both referring to the length of an object. If we're being really precise in our language, length is the concrete length of something in 2 or 3 dimensions, whereas norm is the abstract length of something that may be in higher dimensional space. And the real big picture takeaway from everything that we've discussed today, in particular related to dot product, is that when you're computing the dot product of two vectors, you're going to get something positive when the angle between is acute, negative when the angle between is obtuse, and 0 only when you have orthogonal vectors meeting at 90-degree angles.